Welcome everyone. Thanks so much for being here with us. I know it's already the last session, but yeah, I'm very grateful to see all of you here. We're making sure that we're going to do use the most of your time here to introduce AI for Spring developers. My name is Sandra Ahlgrimm, and I'm here with Timo Salm. You can already scan the QR code for the Slido if you want.
For those that missed it, it's also available on the schedule, the link.
Okay.
Okay, perfect. So let's start with the introduction.
Yeah.
I still see some smartphones.
Okay.
So actually, my name is Timo Salm. I'm a pre-sales specialist at Broadcom. So with the acquisition of VMware and Pivotal, which I joined in 2019, we are, for example, the vendor of Spring. Usually Broadcom is more popular for semi-computing and chips, but yeah, they also have some software like platforms. And yeah, in my pre-sales position, I'm actually there to educate customers about our products and try to help them with their problems.
Yeah, I'm Sandra Ahlgrimm. I'm a cloud developer advocate working for Java at Microsoft. Yes, we use a ton of Java ourselves as well. You can find me on Twitter, on LinkedIn, and both of us on the normal socials like Blue Sky. So let's start with a short introduction on generative AI. So whom of you is already an expert in AI? Like who's using it? Who has heard about it? Who is familiar with the terms? Who knows what a prompt is? Okay, that's already a lot. So I will keep that short and sweet to not miss anyone. So generative AI is just a subset of AI. AI is like a concept that already appeared in like the 50s. So usually it turned out to be first in movies, like in cinemas. So what a funny coincidence. Where we thought that AI would be basically like computers being able to think as humans. And then we shrink it more down with machine learning and deep learning. So thanks to all the data scientists and Python engineers who made all the effort in training models, fine-tuning them, getting from machine models to foundation models to large language and small language models. That's all the great work we were just going to use as Java developers. So I guess most of us here are like backend developers. Okay, fine, great. So you're the perfect audience here. What we really need to know is like very short, what is a prompt, what is a token? So a prompt could be like Berlin is, and then we let it, the chat model to give us the next tokens. So, and you see a token is just a subset of characters. So it can be a word, but it can only be like 3 letters. And then the LLM will only just give me the next token based on like which is more likely. So here it's Berlin is more vibrant, diverse, innovative. And then it only gives me like the next token, which is the most likely one to be chosen. It doesn't check if it makes sense overall, so it only works on token by token. So that's usually something we should keep in mind here. So why are we doing it with Spring, Timo?
Actually, it's like, yeah, so we chose Spring as a framework here, even for those people that are not Spring developers, so maybe Quarkus developers or Java EE or Jakarta EE nowadays. Some of the frameworks we actually will introduce, they also work with other frameworks. So it's like we will use Spring and also the demos we have. So we have a repository with demos and also the slides later, which you can just use. And at the end of the talk, we will share the QR code for that. So feel free to have a look, and even if you are a Quarkus developer, for example, because the core concepts and APIs, they are similar. It's more about the integration into Spring, which we'll also show. Okay, so the first question is why Java or AI frameworks in general. So as you can see here on the right, usually every AI provider is offering REST APIs to interact with those models. So it's not like that you have to integrate them directly in your code, etc. Usually it's just like interacting with APIs, as you know. But it's like, first, those APIs, they change very often based on the features. And secondly, it's like, as you can see here with this example, from a usability perspective, maybe there's room for improvement. And what usually those frameworks add is a higher abstraction, so that you can easily use those, and for common patterns and also advanced functionalities like retrieval augmented generation or tool calling, which we will also introduce later, it makes the use a lot easier with still the flexibility to go down this abstraction and maybe adjust stuff or also use specific functionality that's only available with a few models. The big benefit of Java AI frameworks is because, initially the Python community is the one that's really known for all this AI stuff and machine learning, is that you can stay with the language you love and you're used to and don't have to switch to Python if you only, for example, want to integrate AI capabilities into your enterprise applications instead of actually, for example, fine-tuning models or something like that, which then would be done by someone else in your company with Python skills, etc. And so what do we want to do today? Actually, it's like we chose 3 frameworks, and we have one demo application, Sandra will introduce you in a second to, which we implemented in all three of those frameworks. We will compare them based on the functionality they provide, the usability, and to be honest, at the end it's like that's just like from our perspective, so feel free to have a look at the source code repository, try it out yourself, to actually then decide what is the best framework for you. So we start with LangChain for Jane. Actually, it's like the first Java framework for AI, available since early 2023, and it was really at the end influenced by those Python libraries. So LangChain is a Python library, and this is also where the name is coming from, but it's not like a direct port from LangChain. It's more about ideas, concepts, and the experience is in a way translated into Java, but they also have concepts from Llama, Index, etc. The benefit of LangChain for Jane is that it's really framework agnostic, which means they have integrations into Quarkus, into Spring Boot, and you can also use them without the integrations because they are really, as that, framework agnostic, so they're not using any functionality of those frameworks. The GA was announced today, so which is great. I'm not sure for our talk or for someone else's talk, but GA today. So feel free to have a look and try it out. And at the end, it provides a lot of functionality to you to enrich your Java applications with AI. The next one is Spring AI. I'm really proud of that project because I'm from Broadcom, but actually it's offering a lot of similar functionality. It's also, in a way, influenced by LangChain for Jane, and so it has similar concepts also, but also stuff is different. For sure, it integrates really well into Spring. Because it's implemented by our open source contributors. For sure, we also have a community. They also heavily support there. It's starting with Spring Boot 3.4, which is also important to know. So if you have an older application, maybe with Spring Framework 2.7 or Spring Boot 2.7, you have to upgrade first to get those features. We have enterprise support for it, so that's also good compared to, especially compared to LangChain for J, because that's really community driven. So a lot of different companies currently are contributing to that. With Spring AI, because it's a little bit different, we are able to provide enterprise support. The GA will be next week, the announcement, I think, was prepared for Spring I/O in Barcelona, so looking forward for those people that will be also there to meet them there for their announcement. And then, last but not least, we have Semantic Kernel, cross-platform actually framework from Microsoft, which is also providing all the AI functionalities you are aware of. What's special about it was first started for C# and Python, and Java was added afterwards to give those Microsoft customers really the same experience across different programming languages, or at least all the programming languages in enterprise world. The framework is also agnostic, which means that you can use it with all common frameworks, also Java, Jakarta EE, for example. And it's because it's like created by Microsoft, even if it's open source also, they also offer enterprise support here.
Okay, so let's demo the sample application. So we created a recipe finder. So when I have to cook something. I'm not the best cook, so I need a recipe always. And then I will just give it the ingredients here, and then I should get it. So let's see, that's the code. That's the demo app. So I can just, it's running on localhost, and then I can search, for instance, for cheese. And you can also see this one is powered by OpenAI. We're using the GPT-4o model and OpenAI with DALL-E 3 here. And then I can just click on find. And then I will do, and in the back end, we have it like implemented 3 times. The GitHub repository will be shared afterwards. Everything is open source, and the front end actually looks always the same. So I will only show it once because user experience will stay the same. Okay, so it will get this one, I guess.
Yeah.
It's always good if it takes a bit. So if you're talking about performance, it's not really the Java code that matters here. Actually, it's usually the LLM and how long it takes for it to answer.
Yeah. In most of the cases, it's about like the image generation. So the image generation here, as said, will be done by DALL-E, and this usually takes the most time. And the image generation will be the image will be created based on like the name of the recipe that will be generated by the large language model.
Okay, so here's the code. First, you always have to stop. What? Stop? Oh, yeah, sure. Okay, so LangChain4j first, general concepts. So we have the highest abstraction, which is the AI service. It's always a good practice to start with that one, because then I can change very easily the underlying concepts, like the underlying ones, for instance, the low-level APIs, such as chat model or image model, but also using different models. As we said, we're using this wrapper because then we can, to go away. Then we can switch between different models, or we can check how they're working. Also, we are independent. Like, I don't know if you heard about it, but OpenAI just released the new Java SDK, which is based on Kotlin. Obviously, I can also just work, it's based on REST API, right? I could also build my own wrapper, but then you have full control, but also full load of maintenance and to take care of it, to change it every time something changes. So it's always good practice to go here, also with the highest abstraction layer. So we try to do that. So here's the code. When I start creating the Spring app, I will go on start.spring.io, or I use the Spring Initializer plugin available in all my favorite IDEs. Here we're using IntelliJ. So I have my dependencies, like the normal Spring things, and then I need to add the LangChain4j dependencies, such as the Spring Boot Starter, which will come with the auto configuration. Then I am using the Llama one, so I will also use Llama, OpenAI, and Azure OpenAI here.
And that's actually special about our application, because the idea is that you can, in a way, have a choice between the providers, and therefore also some code in the application is would be a little bit easier without this multiple models for the same purpose. So usually all of them support that you have multiple models, a different model for image, a different model for embedding model, and different model for chat. But it's like we're using here 3 providers in one application, which can be configured via configuration properties.
Okay. Then I have my different profiles provided by Spring. So I have my application YAML or the application Azure, where I can define my keys and deployment names and what's needed. And here would be like the default configuration, just to show how I can easily switch then afterwards. Here's my service created. No, first? Yeah, okay, fine. So here's, I'm fetching the recipe for. Yeah, we have 2 ways of implementing this. One is without annotation, and the other one is with annotation. Is the right one, right? Yep. Okay. So I'm fetching the recipe. So first, the one without annotation. So I'm a Java dev. I'm switching constantly frameworks. So for me, sometimes it's easier if I'm not having so much hidden with annotations. But then, let's see. Let's just compare. So I have the system prompt I can just use from ClassPass templates, and also for the user prompt. And then I can use the builder here for the AI service, define my model. Here I'm using the chat model, and then I just build the request. And for the user message, I do have a user prompt template available in LangChain4j that I can use. So it's pretty cool. I can only just, apply like here ingredients. So in this case, this is my business logic, right? So we have a recipe finder, obviously, but for you, you always have to translate it in your head, in your business context, right? So here I have the ingredients, and I get them as strings, and then I can put them to my user message. As we said, those prompts are from ClassPass, so I really like the separation of concerns here. So I can separation of concern. So here I can recipe for ingredients. So here I have the prompt, and it's in a separate text file, which allows me to also give it to other people, like, to non-engineers, for instance. Oh, no, I think they're called now prompt engineers. So it's good, so they can work on those. They don't have to be Java experts. They can work on those and help me with prompt engineering skills to get here better. And, okay, so that's the one. And the one with annotations, I will have to go, for instance, here. So when I'm calling those, here's like the AI service without annotation. I need to give it like the user message, because unfortunately it's the same name. So for the import, and with annotation, it will use the user message from LangChain4j service. And here, it looks a bit more complicated because we are like, by purpose, using the explicit wiring mode, because then we can configure what we want to use in the end. So that's how, for the simple demo here, I would have leave out the tools because that's for a later demo. And then I would just have interface, get recipes, and then I define again the user message just with annotations, give it like where it can find it. Also same for system message, and then it's basically just a recipe find. So what's worth mentioning is we have built-in structured output support, which is very important. So we get already the recipe back, and it's important, for instance, for agents. So if another, like I could also retrieve the information and do the, like get it to an object myself. But if I want another AI service to get the information, I already need somewhat structured output support to enable my service to do so. Okay, I think that's it for LangChain4j.
Yeah.
So let's see how it's done in Spring AI.
Yeah. Perfect. So actually, because I would say, because of the influence, there are similarities. So it's like you can see the base API or the low-level API is the same. So you have a chat model, we have an image model class to interact with the models. You can do that always if you need more flexibility, but actually it's like it's a lot more code to write, especially if it's about advanced features. As a high-level API, we have the chat client API, which offers really a fluent API. So you can configure all the stuff with a really, I would say, nice abstraction. We have one more thing here, which will be really relevant later at the topics, but actually what the advisors are. So as that, so those how you interact with the model on the low level is just via HTTP requests and REST requests here, or REST in general. And what those advisors do is like you can inject into the request, so before the request will be sent and afterwards. And you can use this, or this is how you would, for example, implement logging. So if you send the request to the chat model, you intercept the request, add like a logged statement that logs the request, for example, and then if you get a response back, you log the response after it's actually sent to you and then handled by the rest of those advisors. So the advisors, they are really a chain, like it's a hierarchy, and with that, as said, you can also add context, additional context, in addition to the user mesh that you have, etc. So that's another really important concept here of Spring AI. If we have a look at the code to see how the experience is, so we also have the dependencies. So everything with starters for sure, because it's in a way Spring native, I'd say. We also have the starters for those different models, and then those for the application. If we have a look at the application properties, you can see that there's some things a little bit different. So if we go to the default one, we can see that you always have the chance to define for every model you'd like to use which provider you'd like to use, because of the fact that it's like really well designed from a way that you can have different providers for different proposals. You have all the auto configurations, so like with LangJ4j, there was not too much additional configuration necessary, or nothing, to actually use those services on this high abstraction. And if we have a look here at the service, so how it's implemented, we also include all the prompt templates as resources. And for the code, actually, this is the code we write. So it doesn't provide as many annotations than the integration of LangChain4j into Spring. So all those annotations you saw, they are like for the Spring integration. If you would do that without Spring, you would use the broadsheet Sandra showed first, so like with the code. And here what we can see that you have the chat client API, you start a new interaction with the prompt method, then you can add the user method and also have this templating capabilities like with the ingredients placeholder. Then you just have the call, and here you have the structured output with a .entity recipe class. So that's like the experience with Spring. And then also for advanced features, etc., it's the same experience on this high abstraction. Okay. So yeah, we have another framework.
Yeah, we also have Semantic Kernel for Java. So as Timo already said, it was built first for .NET. So some things might work a bit differently than the first one we've heard. So here we're putting the kernel in the middle. It works like a diversity injection container, so to say, that will manage all the AI services and toolings for us. And yeah, why don't we dive into the code, right?
Yeah.
I think let the code speak for itself. So here we have Semantic Kernel. Let's start first with our dependencies again. So here I'm adding the status for Spring Boot. And then you can already see. So here we have the Semantic Kernel API AI services. You see there's nothing specific for Spring Boot here. So you need to do all configuration by yourself. So here we see the auto configuration. We needed to create it ourselves. Here would be like a bean for the check completion service, like for the OpenAI completion service, or here another one for the Azure OpenAI completion service. You know, it's not hard, but you know, having a good Spring Boot starter could solve some issues here. And then you need to configure the recipe finder, like as we had to do it for the other ones. But here we put the kernel in the middle, so we're defining our default kernel, give it the check completion service, and then build it using the kernel builder. And here you can see how we would fetch it. It's down, right?
Yeah, yeah.
Okay, yeah, thanks. So here's the fetch recipe 4. We can use again the prompt resource again from the other files. I think that's a best practice you should always do. So sorry with the microphone. And then also for the user prompt. And we can, yeah, for prompt templating, you can also see that we're missing a bit of like support here. So we had to do like some string joins to get like the same results as we have with LangChain4j and Spring AI. Then I can use the kernel function arguments builder to give it like the ingredients here to build that one. And then we can put some settings here, and yep, here we're getting the results. So the good thing is we can configure more. So yes, more control, okay. So we can give it here that we want a JSON schema response, the maximum token size. Then we give it here the recipe. On the other hand, we have to define the same thing here again. Okay, fine, but at least we have the control, right? And also it has the structured output support, which is very important for us and for the later on using agents. Yeah, I think that's in the nutshell how Semantic Kernel works. And why don't we go ahead with the comparison. So for LangChain4j, so we put in here, so I want to stress out first that we do have various framework support, right? We do have great framework support also for Quarkus, Celadon, and also Jakarta EE, so that's potentially important for some of us. Then when I'm looking at it as a Spring developer, it needs some familiarity, so it was a bit easier as a Spring developer to dive into Spring AI compared to LangChain4j, but that's a personal opinion, so it's basically up to you to try it out yourself. We also figured that the Spring Boot auto configuration is already there, but a few things we still had to configure, so there might be some things we could enrich here. It's an open source project, so it's also on us to create GitHub incidents and push PRs for it. Same for the documentation, so you can really see that there is like, it was built as a true open source project just by someone, by Timo, and now he got hired by Red Hat, but it started a bit differently than compared to Spring AI and Semantic Kernel. So yeah, we see a few things lacking in the documentation. You have to be coming soon things, and also like just references to other documentations, for instance, for the Quarkus examples. So yeah, there is things that can be improved, but as I said, it's a community project, so if you like it, we are all welcome to change it and to add things. And and it has rich tutorials, but then we have also identified that we are like different learner types, like I learn with code, so actually I don't open so much documentation, I'm like checking out the code and then just work with it. I'm curious, who's using documentation when you do new things? Okay. Yeah. Oh, okay, that's most. Who's using who's using tutorials? Also a few. Okay, and who's just checking out the code and see how it works and debugs things? Okay. Yeah. So it's totally worth mentioning that we should work a bit more on the documentation, even though it's already very good. Yeah. And how's it with Spring AI, Timo?
Yeah, I think the first talk I will do is about seeing or finding the value of documentation, because it makes a lot of effort to read through a complete documentation, because then you can understand the concepts, etc., and what's available. Just a joke beside, but actually, like from my perspective, Spring is a really, really good choice if you are a Spring developer. So that's, from my perspective, something that LangChain is a lot better in like this open support for also other frameworks, but on the other side you can really see that like how with the ease of use, etc., that it's really focusing on Spring and they don't have to do any compromises. So it's like for Spring developers it's a really good choice, and it's always hard to keep up with the latest and greatest in the AI world, as you can imagine, and resources are limited. So I really recommend, even we have this comparison, and it's from our perspective, to always have a look like what is new at, for example, LangChain 4j, what is the latest new features in Spring AI, to actually see what's possible with those Java frameworks. But because of the influence, it will not take too much time until probably the other framework has the same support for functionality. And last but not least, we have Semantic Kernel.
Yes, we have Semantic Kernel, and as you can see, Microsoft seems to focus first on the .NET and the Python version, and then Java comes, as the potentially not the most liked child here, but we also have customers using it, and it's getting better, and we are also like a highly data-driven company, so the more customers who are using it, the more effort we can put into this, and the more resources we are allowed to put into that one. And again, this is just a moment kind of thing, so if you're also checking the recording, it might be worth checking how it is nowadays, because I assume, for instance, the documentation also for LangChain 4j will get a lot better by then.
And one thing to mention here, so all of those projects are open source projects. So feel free to contribute, and even it's like with the opening issues about stuff that can be improved, so you don't have to do the work if you don't have the time. With the community, I hope all of them have a bright future. Next, let's have a look at more advanced features. So actually we saw like the most easy examples. You have like a prompt for a chatbot and you'd like to have an answer for that. But the problem with limitations of current large language models are usually the context size, which means you can also only put a limited number of characters into the prompt, so in the request for the large language model, and therefore, especially if you have a lot of data, you have to select the data that is relevant for your context and in a way adjust the context or add this information. And there are several solutions available to adapt those foundation models. The first one is about adjusting like the different or adjusting the foundation model to your specific data and needs, because it's trained of a huge data set, and therefore if you have really special expertise or knowledge in the company, that's probably, or in best case, not part of this model. But that's something Java developers will not do. So as said, that's something your maybe you have a separate department that's focusing on adjusting those models, or you don't have that because you don't have the resources to train those models. That's also fine. Then you need other ways to actually provide your context and make the model behave to your business problem and provide relevant answers. And for that, we have the most easy way of actually adjusting the responses of the large language model, and that's via prompt engineering. So there are a lot of methods available, and for those that are just getting started, I really recommend to have a look at online resources. There are a lot of guides about prompt engineering from all, I would say, big vendors, how to improve it and how to improve those responses, and actually also like you can see this in the sample. There are system managers that try to adjust like the response, and if you just, for example, remove the text there and run the same request, you can see that, for example, the requests based on the mapping, etc., with the JSON will fail. So it's like you can really do a lot with prompt engineering, but as said, for this context limitation, that's something it will not really solve. And for that, another really powerful feature, because at the end, large language models, they are trained on data from the past, which means that you need something that is really up to date or something from an internal system that you have. It's necessary that you provide this in the context of the large language model. Fortunately, you don't have to actually make the decision whether you need a tool for a request or not. Tool calling is something that helps you send this information about APIs or functionalities that you have in your application available to the large language model, and the large language model can decide whether it needs this information from the tool and also send back to the client parameters it has to send to the, or you have as an application to send to the function, and then after that's executed with those specific parameters decided by the large language model, this response will be sent back as additional context to the large language model, and then you get the final response. So you actually enrich the context with an actual data from APIs, etc. And that's something, it's getting more and more powerful, which we'll see later, and more relevant because of agentic systems. The last thing I want to mention here is retrieval augmented generation. That's another technique to extend the context. The idea is that you have, for example, databases with a lot of data, and you're not able to send everything with a prompt. And for that, you in a way need a selection of what data is relevant. For sure, if it's about, okay, it's for a specific user or something like that, this is something you can handle in your code. But if it's like, I have this request, so the user prompt in natural language, how can you translate this into a SQL query? So that's a problem you have to solve, and therefore we have components and functions, so a vector store and a similarity search, and then you can translate via an embedding model, which is also like the core of those large language models. You can, in a way, translate like your user prompt to a vector. This vector will be then done with a similarity search, run against the vector database with your data, and then based on similarity, it will return relevant results. So the question is, how do you get your data into the vector store? For that, you have, again, use an embedding model. So first you need a pipeline that, for example, loads PDF documents, extracts the information there, and also for the context side, it makes sense then to separate or split those documents. And then with the embedding model, it will be converted to vectors and also saved into the vector data base. And that's something I would say all common AI frameworks have support for, because it's a really important feature. But also there, it's like, it's so moving fast that every few months there is a new capability, a new technology, or a new protocol to implement this stuff. So it's always important to, in a way, if you implement this stuff, to keep up with the pace and, in a way, keep yourself up to date. So let's have a look how it's implemented in our recipe finder. Actually, the experience here is really basic. So for sure, we could also have just created a chatbot, but yeah, from my perspective, it's not always the best user experience. And therefore, what we have is we have two checkboxes. So the one is use available ingredients. Unfortunately, we were not able to get our fridge here with an API to check what's inside the fridge, but that's more or less a mock of this functionality. So it will return what ingredients you have in the fridge. So here it's cheese in our sample, which is hard-coded. In the code, you can see that it's bacon, for example, that's in the fridge. And if I click that and click on generate, there should be, in best case, a recipe with bacon. So that will maybe take a few seconds. I can show you the result. So now it's a cheese and bacon quiche, for example. Retrieval augmented generation, we first have to import a document. For that, we have chosen here recipes provided by the German government. For those people that are not from Germany, feel free to reach out and download them. And yeah, if we have this cheese, bacon, it's really probable that we will get back, because of our retrieval augmented generation and the documents or the recipes, that we will embed this recipe here about Spätzle muffins. And so if we do that, we can see also this finished here. It's a different recipe because it's like a large language model, which is actually not deterministic. We can change this or adjust this with the temperature, but here we want to have some creativity. And so if I would check the preferred own recipes, we can see that that's the result, which will be returned, as I mentioned, because of the fact that, yeah, the context of this recipe is based on the vector search embedded. So let's have a look how easy or hard it is to implement those functionalities.
Yeah, so LangChain4j helps us with the tools calling support. So we do have the tool specification API, and then I can just use that one and then annotate with add tool all the methods that want to like use tooling support actually. So and then we also have rec support. So we have classes like the document loader or the document parser, also document splitters that will all help us to get the data into our vector stores, yes. And then we also do have the embedding models, embedding store, and also the embedding store and gesture available to help us here. And then finally, to retrieve the data, I also have the embedding store content retriever that helps us implementing native rec. And we also have additional support for advanced rec. Unfortunately, due to timing, we only implemented this simple one. So let's see how the code looks like. So here's LangChain4j. Again, let's start. First, we need to check that we have all the necessary dependencies in place. So we do also have a Spring Boot starter for Redis, so that should be easy to use. Then we're going to use the Apache PDF box parser to retrieve the data from the PDF file. Okay, seems to be a bit of configuration necessary. Okay. So here I get the configuration for this. So I'm having to use the embedding store content retriever here with the embedding store. I can also specify how many results I want, what's my similarity index, so how creative can I get here. And then I build that one, and I also do the same for the embedding store and gesture. And here I can also do I have to specify the document splitter, and here I need to be aware of what's the context size of my specific model. So if you see errors, you might have to play around or go with the document splitter a bit more far. And then I'm building that, and then I can already use it here in my AI service. So as I said, here we're going to use a bit more Spring native way of things. Let Spring do a lot of magic for me by using annotations. Here I'm using the explicit wiring mode because that allows me to here just specifies the tools that I want to use, like here the recipe service. I gave it the user message, the system message, and then I just do recipe find, and it will do all the magic for me. Almost same for the rec. So here I have to give it the content retriever. So where do I get the message or the vectors from? And then it's the same thing, right? Recipe find, ingredients. And I can also mix and match. So that's pretty cool. So I can also use tools and the rec. It's extremely easy after I did, obviously, all the pre-work with configuration and use the Spring Boot starter here.
You can also show the add tool annotation.
That, yes, sure, it was in the service, right?
Yeah.
So, and also here the add tool annotation that was missing. So here I had to do this one as well. So here I used the add tool annotations that we talked about before in the slides, and then I just, can do a log and then also just return the available ingredients in the fridge.
So actually it's really easy to define those tools and register them. And as said, for some frameworks you can also decide whether they have to be called or not, or for some APIs, for others not. So it's really the job of the LLM to decide whether they want to call that, and then they send you a response with the parameters that you have to call it in the code, which will be all handled for you here, and then send back with additional context.
How easy is that in Spring AI, Timo?
It's okay. As said, so it's influenced in a way, so you can see similarities here. So we have this interface of the API of a tool callback, and then we have the add tool annotation to provide all the metadata for the tools. And you can imagine with Spring, we have a lot of auto detection, etc. So it's minimal effort to actually also register them. Similar for retrieval augmented generation, so we have classes to really support this ETL process, so like extracting the information from the documents, transforming them and loading them into the data store. We have abstractions for the embedding model and the vector store, and a lot of implementations like LangChain4j, so Redis was just an example here. And then, so you can see it's an advisor, so this is why I introduced you to this concept, so that's also used here. So the advisor, there will be a request coming from your client. It recognizes, okay, retrieval augmented generation is enabled. So I do all this retrieval process of getting the data for the user prompt from the vector store that's relevant and putting it in the context for you. We also have a more advanced advisor, which, so comparable to LangChain4j with the advanced retrieval augmented generation, where you can, for example, do routing. So if you have multiple sources, multiple vector stores, etc., you can get information from them. So let's have a look at the code. At the end, it's like also we have to add the related dependencies, as you can see here. So the vector store for Redis, the core library, and also the readers here for PDFs, because we'd like to include PDFs. And if you don't have other sources, other documents, you for sure don't need this PDF support. Then from a configuration perspective, you can see I don't have any configurations here because of the fact that in this case it's completely auto-configured. And if I go to my implementation, let's first have a look at the tool calling. So there in my Fluent Jet Client API, I just have this .tools, with, which is in this case the object where those tools are registered. In this case, it's in this class or then instance, and therefore it's just this. Here is like the call for it, the tool for it, the tool definition, which is really similar to the one at LangChain4j. And I then, from a retrieval augmented generation perspective, I have this advisor here, so the rec advisor, which I create with a builder, with a vector store, a search request, so that's additional configuration, like how many results I'd like to have, the similarity threshold for the data, and then also an additional prompt template. So from my perspective, it's really great that this support is also there on the high level, because usually if you have retrieval augmented generation, you want to have an additional prompt to the user message. In this case, it's like if one of those ingredients is available in your recipe that is like coming from the database, then use this recipe unchanged. And that's the experience. So you can see I only have to configure a few lines of code. For sure, I also have like this import process, which you can see here, where I can decide how I want to split the documents, etc., depending on your documents and the requirements. The same is available for LangChain4j, so they also have this like pipeline to actually load the data and split it. And yeah, so that's it. We're going to time. That's it about Spring AI. We also have, as said, implemented the same for Semantic Kernel. It's a little bit different, but very similar, as you can see. It lacks a little bit in support of the abstraction for retrieval augmented generation, but it works, which is great. And source code is available, so feel free to have a look to see like the differences, how it's implemented. And the last thing I want to talk about before the final comparison is agentic AI. So actually, it's like on the left, this is how I would say most of the intelligent applications with integration to large language models looked in the past. With, for example, this example of retrieval augmented generation as a pattern. So you have an application that is fetching some data from a database and then sending it to the large language model as additional context. Retrieval augmented generation, as mentioned, is only used to reduce the context, because otherwise we could just send the full data to the large language model, which is not possible because of this limitation of the context size. I would say, yeah, since last year or something like that, this is a little bit changing, because there is this new concept or idea of agentic apps. So that those large language model, they got a lot more autonomous, which means that they make the decisions whether they have to call or get data from a database, call an API, etc. And then the information flow looks a little bit more like here on the right. So you have an application, you have a request, and the large language model, like with tool calling, or that's actually the base of that, the base functionality of that, is deciding whether it should call an API, call a tool, etc. The question is, with all the capabilities we'd like to have, so let's imagine you have all the tools that you use in your daily work connected to ChatGPT or another chat client, chat solution. That would be impressive, because then you can just like, instead of doing all the steps yourself, you can just put in the prompt, what you'd like to have, it will be done for you, and yeah, you have a lot more time to do a really important stuff. And actually, this is like the problem that's trying to be solved by the so-called Model Context Protocol. So it's an open source protocol to really define how the communication between LLMs and the different tools and APIs is standardized, or how they connect to each other. And that's also something for sure, those Java frameworks and other frameworks, they have to support that. And that's something we are heavily working on, and yeah, so we didn't have implemented here. So for the recipe finder, I have a Spring AI sample of MCP. So how to implement the same solution as a server and as a client. So a tool will be a tool that will be used, and something that's consuming it. If you just want to have a look how that looks like. And yeah, here is the final comparison of those advanced features. Say.
Okay, LangChain4j, yeah, we had very great tool calling support. It even got copied from other frameworks. And we also have seamless integration of RAG and advanced RAG. And then there's the vector database integration. Yeah, for MCP, we only have clients, but there's the MCP protocol that the Spring team implemented. It's actually language agnostic, so we can, framework agnostic. So there's no reason not to have a server at some point, or we join forces and contribute to the same one. For Semantic Kernel, we're quick, as you can see. Yeah, there's space for improvement. So looking forward to that, definitely.
Yeah. And yeah, so especially I would say regarding that MCP support, because we wrote the Java SDK for MCP, we are a little bit ahead of the other frameworks, but as said, so they will really soon keep up and have the same functionality, etc. available. So I wouldn't, if it's not like your main requirement, I wouldn't choose like a framework just because, oh, they have this small feature more than the other one, because they're all looking at each other and see what they provide and whether it makes sense for them to also add this functionality. And yeah, so that's it. The summary is, it looks like Enterprise Java is ready for Gen AI, especially with the GA releases of those frameworks. So today, LangChain4j, next week, Spring AI. Semantic Kernel, as far as I know, is already GA. So yeah, just a few more features to add, and then you can also really good use it. And the recommendation here is really, so for sure, there we are in a way opinionated, but I really tried to not be opinionated, and when we implemented, we just saw that some stuff is like missing, like in the documentation, or it's a lot harder to get it working, or it doesn't feel that natural to Spring. But yeah, it's really important that you make your own experiences, use cases, and yeah, with that, thank you very much. As said, here is the QR code for the source code. Feel free to have a look and also provide feedback if you'd say, yeah, that's maybe something you can do better, or if you have questions about that. And yeah, we will also upload the slides as a PDF to this Git repository.
Yeah. Okay.
Thank you very much.
Thanks you very much. You have been a wonderful audience.